Come back. Let's look at hyperbolas. A hyperbola is the set of points on the coordinate plane, the difference of whose distances from two fixed points f1 and f2 called the foci is a constant. So in the previous case when we were looking at ellipses, it is the sum of the distances should be a constant. For a hyperbola, it's the difference. This distance minus this distance. Notice difference meaning you're looking at absolute value. So here is something. This distance minus this distance. They should be the same. So no matter on this curve, difference between the two distances have to be equal. So suppose my two foci are on the x-axis. F1 is negative C0, F2 is C0. Let P be any point on the hyperbola. That is, distance from P to F1 minus distance from P to F2 is some twice a number, a real number. Let's see. Distance from here to here, distance from here to here. So let's calculate. Let's use xy. So xy 2 minus c0. So that gives me, using the distance formula, root x plus c quantity squared plus y minus 0 quantity squared minus distance from P to F2, root x minus c quantity squared plus y minus 0 quantity squared. This difference has to be twice some real number, positive number. Move the negative radical to the other side. Square both sides. Similar argument as we just saw for an ellipse. So when you square it, the radical goes away. Here you are going to use complete square formula. Square of the first term plus 2 times these two plus square of the second term. When I square a radical, they go away. You have x minus c quantity squared plus y minus 0 quantity squared plus 4a radical plus 4a squared. This gives you complete, open the complete square, right hand side open the complete square. We have just kept the radical part as it is. Now cancel what you can cancel. Move the negative 2cx over here. So it looks very much similar. Divide by 4. Continue. Move cx minus a squared. Continue squaring both sides. Upon all the same work, when you finally divide by a squared times a squared minus c squared, this is the quantity you get. But what is the situation? Now this looks very much like an ellipse. But in this case, a squared minus c squared is not positive. If you think about it, a is the difference, right? Represents difference of distance. Right? Difference. Whereas c, twice the distance, is the sum. So in fact, c is bigger than a. All right. So c is bigger than a. So I need to interchange these two. All right. When you interchange these two, a negative is incorporated, so that becomes a minus. Now c squared is greater than a squared. So that's a positive number. So there is a b number, real number b, whose square is that c squared minus a squared. In other words, c squared is a squared plus b squared, and we'll call that b squared. So you notice in a hyperbola, you have a difference of these two expressions. X squared over a squared minus y squared over b squared is 1. When y is 0, you get x-intercepts. They are called vertices. But when x is 0, because of the negative, you have no y-intercept. All right, there are no y-intercept. So summary here is foci on the x-axis. When the foci are on the x-axis, this is the equation of the hyperbola. x squared over a squared minus y squared over b squared is 1. C squared, that is the foci coordinate C squared is a squared plus b squared. The foci are on the x-axis, negative C0, C0. The vertices correspond to A, negative A0, A0 on the x-axis. The curve is asymptotic to these two lines. Y equals b over ax and y equals this one. That is y equals b over ax, and this one is y equals negative b over ax. All right. So the curves are asymptotic to these particular lines, intersecting lines. So this is when you have foci on the x-axis. What happens when you have foci on the y-axis? Well, in this case, A goes with y. Y squared over a squared minus x squared over b squared is 1. C squared is still a squared plus b squared. The vertices are on the y-axis. Foci are on the y-axis. And hyperbola is asymptotic to the following lines. Y equals a over bx, y equals negative a over bx. All right. Here is an example. Find the foci and vertices of the hyperbola. X squared minus 9y squared is 1. Well, divide both sides by, no, you don't divide by, you already have a 1 on the right hand side. You don't need to divide. You simply rewrite that multiplication by 9 as division by 1 over 9. Notice 1 is greater than 1 over 9, so the minus makes sense. A squared is 1, b squared is 1 over 9, c squared is a squared plus b squared, that is 10 over 9. Moreover, the larger quantity goes with x, so your foci will be on the x-axis. So square root 10 over 3. Yeah, c squared is 10 over 9, so c is square root 10 over 3, negative or positive. So these are your foci, and these are the lines your hyperbola are asymptotic to. The vertices correspond to x-axis. A is negative 1 or positive 1. So this is your picture of your hyperbola. Sometimes the conics are not centered around origin. Like here, this was centered around origin. All the examples we saw, we were centered around origin, but not always is that the case. So sometimes you're not centered around origin. So what do you do? For example, here is a conic, x minus 2 quantity squared, 16 times y plus 3 quantity squared. So that shift is happening because of negative 2 in the x direction, positive 3 in the y direction. Okay, so x minus 2, y plus 3. Which tells us what? Well, here I will divide both sides by 4. So 16 over 4, I will write it as 4 here, 1 over 16 here. Sorry, 1 over 4. It was correct already. That's a 4 and 1 over 4. Okay. B is half. That's here. A is 2. That's here. So notice that's the major value, right? A is bigger. So that's an ellipse. Foci are along on a horizontal level, but no longer on the x-axis. So the foci are on the horizontal line passing through positive 2, negative 3. You see, we are no longer on the x-axis, but we are on a horizontal line. The origin is now shifted to 2, negative 3. So foci would have been 3/4 plus or square root of 3/4. So you would take 2, negative 3 move that point to origin, you see. So instead of negative root 3 over 2, you have 2 minus root 3 over 2. Instead of 0, you have a negative 3. Likewise here. Okay. So now all of these lectures, by the way, closely follow book by James Stewart. Next video, we'll go over problems from web work. Until then, bye.